Now in this lecture, we will see the problems based on DAlembert's ratio test. In the previous lecture, we have seen how to find the nature of the series by using the comparison test and Cauchy's integral test. Now let us find out how to find by using the DAlembert's ratio test. This is another test for testing the positive term series. So here, first of all, we have to find out un and then un plus 1. Then find the limit n tends to infinity of un plus 1 by un, and if it is equal to k. And if k is less than 1, then sigma un is convergent. If k is greater than 1, then sigma un is divergent. If k is equal to 1, then the test fails. So in that case, limit n tends to infinity of un plus 1 by un is equal to 1. Then we have to find out limit n tends to infinity of n into un by un plus 1 minus 1. Okay, now let us see the problem. To discuss the convergence of the series 1 plus 2 square by 2 factorial plus 3 square by 3 factorial, 4 square by 4 factorial plus etc. So first let us find out un and the un plus 1. So for that you will let us take a sigma un as 1 can be written as 1 square by 1 factorial. So 2 square by 2 factorial, 3 square by 3 factorial plus etc. Now to find the un and the un plus 1. So here un is equal to n square by n factorial. So un plus 1 is equal to n plus 1 the whole square by n plus 1 factorial. Now let us find out un plus 1 by un. Un plus 1 is n plus 1 whole square by n plus 1 factorial. Then we can reciprocate this and write like this, n factorial by n square. We know n plus 1 factorial can be written as n plus 1 into n factorial. And from n plus 1 the whole square, if I take n outside, I can write that as n square into 1 plus 1 by n the whole square. By denominator, I can write n plus 1 into n factorial. Then into n factorial by n square. So I can cancel n square, n factorial also I can cancel. And in the denominator, if I write by taking n outside, I can write 1 plus 1 by n. Now I can able to find out the limit n tends to infinity of un plus 1 by un. So 1 plus 1 by n the whole square. So one term I can cancel it. Therefore, this is equal to limit n tends to infinity of 1 plus 1 by n then divided by n. So this is 1 plus 0. So limit n tends to infinity of 1 plus 0 by n, and which is equal to limit n tends to infinity of 1 by n, which is equal to 0. Since 0 is less than 1, therefore I can conclude that limit n tends to infinity of un plus 1 by un is equal to 0, which is less than 1. Therefore, by ratio test, that is DAlembert's ratio test, sigma un is convergent. So hence this ratio test helps me to find out whether the positive term series is convergent or divergent based upon the rules. The next problem, let us see the series of the form 3 by 4 plus 1, 3 square by 4 square plus 1, then 3 cube by 4 cube plus 1 plus etc. Now let us find out un. So here un is the numerator, you see 3 power 1, 3 power 2, 3 power 3. Therefore, nth term will be 3 power n. Denominator, the first term is 4 power 1, 4 power 2, 4 power 3. So nth term will be 4 power n plus 1. Now find out un plus 1. Just replace n by n plus 1. 3 power n plus 1 divided by 4 power n plus 1 plus 1. Now let us find out un plus 1 by un. So un plus 1 is 3 power n plus 1 divided by 4 power n plus 1 plus 1. So into reciprocated, so that I will be getting 4 power n plus 1 divided by 3 power n. So 3 power n plus 1, I can write it as 3 into 3 power n divided by, and here also 4 power n plus 1 can be written as 4 power n into 4 plus 1, then into 4 power n plus 1 divided by 3 power n. I can cancel this 3 power n. And same way, 3 by 4 power n, I can take a common. So therefore, I'll be getting 4 plus 1 by 4 power n. Then into, here also if I take 4 power n outside, it will be 1 plus 1 by 4 power n. So now I can cancel 4 power n. So therefore, I'll be getting 3 by, and even this 4 also, if I take outside 4, 3 by 4, by taking 3 by 4 outside, I can write this as 1 plus 1 by 4 power n plus 1. Now let us find out the limit. Therefore, limit n tends to infinity of un plus 1 by un. So that is equal to 3 by 4 is constant. So limit n tends to infinity of 1 by 1 plus 1 by 4 power n plus 1. So therefore, I'll be getting 1 plus 0 in the denominator. So therefore, my answer will be 3 by 4. So my 3 by 4 is certainly less than 1. So therefore, limit n tends to infinity of un plus 1 by un is equal to 3 by 4, which is less than 1. Therefore, sigma un is convergent. Hope you all understood this. So I have already taught the positive term series by finding the nature of the positive term series by using Cauchy's integral test, comparison test. Now this is by DAlembert's ratio test. Thank you for watching.